Okay, so you did one a lot like this back in example 1. So rather than me guiding you through it, I want you to hit the pause button, try it on your own, hit play to check your answer. So I hope you started by pulling out a GCF, and then you're factoring your trinomials and get some clues from textbook problems, right? Like, check out this. There's a really good chance that one of the top ones will be that. And then, do I have any like factors that cancel? I do. That divided by itself would be 1. 6 divided by 2 is 3. So what remains is 3 times x plus 1, or 3x plus 3. All right, let's talk domain. So domain of both a quadratic and a linear function would be all real numbers. So the intersection of negative infinity to positive infinity would be the same. But now check out the denominator. Is there anything that's going to cause this to be equal to 0? So I could just take this original one, say 4x plus 6 can't be 0. Divide by 4. So negative 3/2 is excluded from my domain. So here it is. Oops, I dropped my union sign. Negative 3/2 to positive infinity. All right, hope you got that one right. I'm going to show you last two things would be two quick get more math questions because you're going to be doing some practice in there. This means f times g of 4. So two ways of doing this. You can plug the 4 into each one separately. And I think that's actually what I'm going to do. So I'm going to find f of 4, and I'm going to multiply that by g of 4. So negative 2 times 3 to the 4th is negative 162, and I need to multiply that by square root of 3 times 4 minus 11. 3 times 4 is 12, minus 11 is 1. The square root of 1 is 1. Well, that worked out beautifully. So negative 162. Not asked anything about domain on Get More Math. All right, and then this is another one in GMM. Given f of x is cubic with 4 terms, and g of x is this, we are, and we're told where g of x does not equal 0. So what's that stating? Well, we recognize if g of x were equal to 0, we have a problem, so they're just restricting their domain. It's their kind of way of saying, hey, don't worry about the domain issues. So I don't think you're going to see many like this in GMM, but once in a while one sneaks in, so I wanted you to have one for an example. So I think we're probably going to need to do a little long division here. Can't forget that. So let's carefully set that up. 3x cubed plus 4x squared minus 7x plus 2. Always check and make sure there are no missed terms. And negative 3x plus 2 out front. So remember, you're asking yourself, you're kind of focusing in on just this first term divided by this one. How many times does 3x go into that? And so what I'm really saying is, what is this term divided by this term? And that would be negative 1x squared, right? Negative 1x squared. So I'm going to put negative x squared above the other x squared. And now I'm distributing. So that is negative x squared times this binomial would produce positive 3x cubed minus 2x squared. Okay, what do? We subtract. So when I subtract, I change my signs and I actually add. So we eliminated, and this would be 6x squared. I bring down minus 7x, and now I repeat the process. So this time I'm doing 6x squared divided by my leading coefficient of negative 3x, and that's going to go in negative 2x times. So now I distribute. Negative 2x times the original divisor would be positive 6x squared minus 4x. I'm subtracting, which means I'm changing the signs on the bottom and adding. 0, negative 3x when I add, bring down the plus 2 at the end. Oh, that works out beautifully. It's going to go in positive 1 time, multiply, and lastly subtract. Gives me 0. So what does it divide to? There it is, negative x squared minus 2x plus 1. would produce a quadratic function. And you're not asked the new domain, so lucky you. That wouldn't be hard to do, it'd be all real numbers except for 2/3. Okay, it's going to be your turn to practice.